Now, I'm almost done. I need to get the other one. I need to get this one up here. Now, I'm going to use a very big shortcut to do that. So the shortcut to the y-intercept, the y-intercept, is to use symmetry. All right, I claim I can stare at this, and I can look at that, and I know the formula for the y-intercept. It's equal to 2y0. All right, that's what that one is. So this one is 2y0. And the reason I know this is the following. So here's the symmetry of the situation, which is not completely direct. It's a kind of mirror symmetry around the diagonal. It involves the exchange of xy with yx. So it's trading the roles of x and y. So the symmetry that I'm using is that any formula I get that involves x's and y's, if I trade all the x's and replace them by y's, and trade all the y's and replace them by x's, then I'll have a correct formula on the other way. So if everywhere I see a y, I make it an x, and everywhere I see an x, I make it a y. The switch will take place. So why is that? That's because that's just an accident of this equation. That's because, so the symmetry explained. Is that the equation is y equals 1 over x, but that's the same thing as xy equals 1, if I multiply through by x, which is the same thing as x equals 1 over y. So here's where the x and the y get reversed. All right, so now let's finish off the problem. Let me finally get this area here. So actually, I'll just finish it off right here. So the area of the triangle is, well, it's the base times the height. The base is 2x0, the height is 2y0, and a half of that. So it's a half 2x0 times 2y0, which is 2x0, y0, which is, lo and behold, 2. So the amusing thing in this case is it actually didn't matter what x0 and y0 are. We get the same answer every time. That's just an accident of the function 1 over x. Happens to be the function with that property.